as you know, our community has been using different type of, let's say, test facilities over years. And it's interesting that now, as Fed4FIRE is arriving to an end, we can benefit from this long experience to understand what should be done next. So as you know, and I will make a long story short, there has been different type of initiatives from the community. So meaning that it was either developed in the US and then built up in Europe or vice versa. And I would like to take, for instance, the example of Planet Lab, because this was an initiative from NSF and Intel, developed by Larry Peterson at Princeton. And then in Europe, we decided, I went to see Larry and I said, look, you will never be able to scale it up. We would like to set up a similar infrastructure in Europe, and but we would like to keep the control over the infrastructure and over the resources, because otherwise I have no argument to get the funding for that. And we decided to invent this federation of infrastructure that actually we put in place in 2007. And that's a good example of a successful facility and, again, a community facility. Ivan is not in the room yet, but Orbit is another example, because different communities were looking at different type of facilities, and again, as wireless was really becoming important, it was vital for the community to get access to an instrument that will provide, let's say, some evidence because of the characteristic of the wireless channel. And again, we can say that Orbit has also been successful, as widely used by the community. But then, over and over, as testbed builders, we have this question. Peter, impact assessment. Can you explain to us how efficiently did you use public funding? And of course, we have been doing this over years, but I can tell you that the question is even much more important these days from the different tools of funding. So we use, for instance, and I won't go into a long development, but we use to monitor. So for instance, maybe it's here, and deep is here, sorry, and we need to regularly go back to the different source of funding and explain again how many users, how many experiments. You can see here, for instance, a simple illustration of this, but you can go to Elsevier and they have tools now that will dig into the data and tell you precisely who has been using or citing your facility. But then it becomes a little bit more complex, because not only we need to serve the academic community, but we need also to demonstrate the value for industry. It's tricky to involve big industry for reasons that we know, but of course, and I guess you will have some examples, then we should provide an access to those who cannot afford it, like SMEs or startup companies. But of course, the capacity metric is very important, so we need also to demonstrate how those facilities are used in different curricula, how many training did we develop, how many students have been using the facility, and so on and so forth. So it's becoming really difficult. Plus, it's very different from other big instruments in Europe, for instance, because we are developing a facility to serve the community. We are not developing a facility for our own usage. And it's very difficult to reward, because again, reward is usually through publication, citation, and so on. So nevertheless, there was a second generation of facilities that were pushing the envelope further, because we try to bring a broader community all together, not only something which is very fragmented, but a broader community with different type of, let's say, targets. So in the US, for instance, the NSF Genie initiative try to develop a programmable nationwide infrastructure with the so-called Genie nodes. In Europe, it was a bit different. The idea, and that culminates with the Fed4FIRE Plus, was to bring different technologies into the same facility in order to provide access to a broader community. That's nice. Still, impact assessment, that will be part of the discussion later on. And I know that for Genie, of course, there was a big debate about whether it was successful and whether it should be pursued. And then, of course, we need to question ourselves about what will come next. And we see important initiatives. So, for instance, in the US, there are quite many now with the power nodes, with fabric, with bridges, with Colosseum, and so on and so forth. But still, at least to my opinion, they are quite fragmented. And it raises this issue about impact assessment and sustainability. And likewise, in China, there are also big developments. In Europe, we have been working quite closely with some of them. We call them ICT. But they are much more, let's say, shorter term impact, much more related to deployment and based on let's say, an equipment, a manufacturer equipment, and trying to see how they can eventually pose some verticals. So this is why, at least, we have to question ourselves, even more importantly, because we are facing a competition that other fields eventually do not face, from the tech giants. And those big companies, as you know, they provide a competitive advantage to their researchers and engineers just because they can provide access to a gigantic infrastructure with data that they can use to provide evidence, although we don't have access to the data. So it's becoming an unfair competition. Fortunately, at least I see it like this, there is a big development these days related to open source software for telecommunication. And then the fact that we have access to some of those components will eventually allow us to use those components to have a more sustainable and scalable infrastructure in the future. So, lessons learned, at least from my experience. First, previous and current generations of test facilities were successful, no doubt. But they are not really recognized as such. Still, they are debated whether it was worth, whether they were impactful, whether the assessment was sufficiently well done. And they are not sustainable. I understand that in the US and in Europe, we have different kind of opportunities for funding, but still there is quite a lot of burden because every 3-4 years you have to think about how you are going to keep it as a sustainable infrastructure. So that's the first point. The second point is that we need to change the narrative. Because if we don't change the narrative, we are going to continue exactly with the same pace, trying to demonstrate that we serve academia, industry, training, colleges, and so on and so forth. And for me, if we want to change the narrative, it means that we need to position ourselves as what we have defined in the beginning. It doesn't mean that we have no interest with industry, it's just the contrary, but that we are developing an infrastructure for science. And fortunately, science-driven infrastructures exist. It's just that we always consider that it's not for us. And this is exactly the reason why 5 years ago, I started to work with the community, and all the community has been, of course, very supportive and engaged, in order that instead of targeting the usual source of funding, which is Horizon or Europe, and of course we continue to address this, we are going to look for this big telescope, using the telescope again, which has been accessible only to other fields. And we are very happy because after 4 years of very strong engagement, trying to understand exactly what you need as a community to satisfy as requirements, minimum key requirements, as they call it, to enter into the slices, the S3 roadmap, we are very happy that we succeed to be on the S3 roadmap 2021. So what does it mean? And we see it as a new generation. So of course, we are going to benefit from the experience from Fed4FIRE, from Power, from whoever, from the community. Of course, likewise for Ignite. I mean, all this experience and skills are most welcome. But the idea is really to try to engage a much broader community with, again, completely new thinking about what should be an instrument for digital sciences. Those examples are actually telescopes. So they are funded by S3. Usually it's high energy physics, it's astronomy, but also you find those instruments in humanities, because they understand actually that they also need data, for instance, and data will fit into those large scale, not mid scale, large scale instruments. To give you an example, one of the flagship of S3 is the, I think they call it the Einstein telescope. It's 2 billion euros. Okay, so it's a different scale. So in Europe, this framework is called S3. So this is the place where you have to send your proposal. Only every 4 years there is a call. The call concerns all disciplines, and only very few will be selected. It's a joint investment strategy between the Commission and the Member States, because you cannot access that level of funding only through the Commission. You also need to have national investment for the nodes. So this is exactly what we aimed at with the slices. So we bring together, because we need to have a sufficiently strong community, we brought together networking, distributed systems, distributed algorithm, HPC, IoT, and so on and so forth, which of course is raising a lot of questions. And the principle is to develop over a long time scale, think that if you build a telescope, it will be available only at best in 10 years. For us, we can shrink it a little bit. We don't have to deploy the whole telescope at once, so we can deploy it progressively. But basically, the good thing is that now we have a sustainable framework. Still, the funding is a bit complex, but we have a sustainable framework. You see what actually is the official timing that has been contracted with S3. And you see that we are still in the design phase. We are entering now in the preparation phase. So design means that the stakeholders are committed, that you convince that there are important scientific questions to address, that you have the relevant community that will put the demand. And you enter into the preparation phase, basically, when you need to put the components all together before you implement. And once the implementation is finalized, then you can operate, and when it has been used for a period of 10, 15 years, then you have to dismantle. So that's a long-term development, which again is certainly much better for us because we don't have to think about those burdens that I mentioned earlier. And but of course, we see, for instance, Fed4FIRE, and Fed4FIRE will continue to support us and bring what has been developed and the different skills. So this is why this is sustainable. We have a quite broad partnership. We got the support of 15 member states at the political level. So it's not only an organization, it's the ministry of that member state who decided that yes, this is a very important development for us and we are going to commit resources. Well, of course, we have strong interest from industry and from different other stakeholders, and we welcome new applications, especially if they can bring very important expertise to the community. So what we want to build is a fully controllable, programmable, virtualized infrastructure. It goes very well within this disaggregation, softwareization environment. And the last point that I would like to make, and I learned a lot by discussing with S3 and by discussing with other fields, is that as long as you cannot manage the full research lifecycle, you are not considered as a science. So meaning that it's good to provide an infrastructure so that the colleagues can experiment with it. But if, for instance, you cannot really manage the data, and you cannot make the data and the software, I mean the digital objects, available to the community, then you didn't achieve much. And therefore, this is why it's important in SLICE. There was a session this morning dealing with open data and all aspects related to reproducibility. We need in SLICEs to organize also all the data that will be collected from the experiments or from the infrastructure and make it available as digital object to the community. That's it for at least my introduction.
Thank you very much.